Well, thank you all for coming. I think this is going to be, we're excited to deliver this workshop. This is something we've been thinking about for quite a while, and we think it's very valuable, and we're pleased to see you all think along the same lines. We're going to be talking about service mesh and how that applies to developer workflows. What are the challenges and the pains that a developer might have, regardless of the language or the framework that they're using, and what can the service mesh do to help alleviate some of that pain?
So, thank you again. I'm this guy here. My hair's kind of growing back to the length of my photograph. It was either that or I had to get a new headshot. But I work at Hashicorp in developer relations, but I am a developer. That is my background. I've worked 20 years building and designing software systems. So I've literally done everything that you're doing now. I feel your pain. We have shared anguish around stuff, and hopefully we're going to solve a lot of those things. And of course, my
name is Christian Posta. I am a field CTO at a startup called Solo.io, where we build tooling to help people be successful with service mesh. For those of you, I think, earlier that raised their hand and said they are running service mesh in production, and maybe for those who are getting their first few steps into service mesh land, you might notice that it's a little complicated. And so at Solo, we're trying to alleviate some of that. But I, too, come from a developer background. My interest in service mesh originally started from the developer perspective. And I became involved in the Istio communities and the Envoy communities and so forth. And I'm excited to be here. So we put our Twitter handles up here for two reasons. One, absolutely feel free to reach out if you have any questions or follow-ups or comments or disliked or disagreed with what we said. But second, I think more importantly, is we're going to be delivering this content in more depth than we can today, because we have a limited amount of time today. But in more depth over the next few weeks and few months in live streams, remote live streams. And we'll be tweeting and sending updates about when and which parts of the material we'll cover through Twitter. So feel free to follow us for those reasons.
Yeah, it's going to be pretty exciting. I'm really looking forward to be able to do that.
Yeah. So this is roughly what we're going to do. We're going to give you an environment that you're going to set up. You can run it locally on your own laptops. If you have access to a Docker daemon, that's all you need. That's the only requirement, that and a web browser. We will also give you an alternative setup where you can just go to an online web training style environment where you can just run everything from the web browser with anything running on your laptop. That might be more preferable depending on how well the Wi-Fi holds up. Because if you run things locally, you're going to be downloading Docker images and that kind of thing, and that might stall out the network. But then we're going to go into the different scenarios that we have lined up for you. We're going to dig into what is it that the developer day-to-day might look like, and what are some of the challenges they might face, and how a service mesh might help them. And some of the things specifically we'll go into is distributed tracing, what it's like to make changes to your services and bring them out into production, and then when things start to go wrong, as they do, then how do we go in and debug them and do this in a distributed environment and do this safely? Go to this link. This is the gateway to the tutorial here. No pun intended, sorry. Go to this link. This will give you the guides for the tutorial. It will give you the links to get to the Instruct environment that you can run through the web browser. And it'll also give you optional tools that you can download to your machine that will allow you to spin up the environment pretty quickly if you have access to a Docker daemon. So I'll give you a second or so to get to that link and open this up. And so the material that we have on this site will be up. So you leave from here, you'll be able to go back to it, and it has all the steps to bootstrap the environment for yourself. and all the steps to go through the content as well, which we'll do today.
Yeah, we built the kind of the documentation around this to be like a traditional resource that you can follow step by step, where we're kind of like not going to read that verbatim today, but it's intended so that you can kind of look at this, you can watch what we're doing, you can kind of see these concepts, but you can kind of go away, have a little think, and you can kind of maybe practice some more play around with those things at your leisure, because I mean, you must be pretty beat by now.
Yeah.
Like 3 days of conference and so many people talking at you, and you just want to go home and watch Netflix. But don't watch Netflix. Do the guide!
All right. Well, let's get moving. I'll have the link at the end too if you didn't get to it. But let me just give you a quick overview of Service Mesh from a developer's perspective. And this is the kind of hit home for me when folks started adopting containers in Kubernetes and building out services-style architectures. And at the time, the state of the art was if you build in these cloud environments where the networks are less reliable than we may have thought previously, and the infrastructure is elastic, and it's constantly changing, things are failing, and so forth. You have to build your applications to live in this environment where things will not always be there. I think in the past we had this, we accepted this premise that the database will never go down, the network will never be slow, and when it did, our applications didn't respond very well to that. In a services-style architecture on cloud infrastructure, you have to make that a first-class thing that you've solved for. And we were writing things in application libraries, things like Netflix OSS. We were putting it into our code. We were entangling our business logic with this stuff that was more networking, things like service discovery and retries and client-side load balancing and so forth. With the service mesh, what we're saying is for those common networking concerns that we would otherwise implement in a language-specific or framework-specific way, let's abstract that out and run it alongside the application so that we can implement that consistently and reliably, irrespective of what language and framework we used. Because otherwise we would have something written in Java, which kind of did, Netflix OSS did a really good job of some of these concerns. And then if you brought in a Golang service, you'd have to go find the equivalent for those libraries, and Python and Ruby and whatever language you wish to use, and you'd end up with a mismatched and incompletely implemented version of these for each of your languages. With Service Mesh, we're saying just to abstract that into a sidecar process that runs alongside your application and solves that consistently. Now, the Service Mesh usually gets talked about in terms of, well, we can solve problems like network security, identity at the application level, encryption for the transport layer, and so on. We can get telemetry to plug into our monitoring systems for operational concerns. We can do traffic routing for releasing new applications and routing around errors and that kind of thing. But the Service Mesh brings this abstraction where as the traffic comes in, it allows us to do these various operational things, and those are absolutely important. For anyone of the developers who are in here and you write your code, if you write your code in such a way that you don't really have responsibility for it, you just give it to the next person to try to run it, then you're going to do some interesting things. And the people on the other side of the wall are going to say, well, now how the hell do I run this thing? Service Mesh kind of bridges that wall or that divide. So traffic comes in, you can get the operational aspects of it, but from a developer's perspective, I need timeouts, I need retries, I need circuit breaking, I need to somehow participate in distributed tracing, I need to debug things, and the combination of these different control points and observability points in the network allow us to do that.
So Christian kind of touched very, very briefly and mentioned this word like data plane, proxy. The kind of the important thing around Service Mesh is the architecture. So we're here to talk to you about patterns. Yes, we're going to kind of use some specific tools, but the key takeaway that you're going to get is that it doesn't really matter which Service Mesh you're using. which kind of tool set you're using, the patterns and the practices are going to be the same. So how kind of does a service mesh work? So kind of in the sort of the guise of Consul, you have a control plane. The control plane is the thing that allows you to kind of centrally store your configuration. It allows you to manage your service catalog in Istio. This is like etcd, things like this. But the important thing for the developer is that you have the data plane. So the data plane and your application are a one-to-one relationship. When traffic flows in or out of your application, it flows through the data plane. Now, configuration of that data plane allows you to do the externalization of things like retries, timeouts, circuit breaking, control transparent encryption around your network traffic, MTLS authentication and authorization of all of those things, and it basically saves you one great big headache. So, the proxy, data plane, proxy, they're kind of two terms that you'll hear, pretty much interchangeable. We have that located in Kubernetes world, it's a sidecar container. So you won't directly inject it into your pod spec. It's something that the service mesh will do for you, but it's there and it exists. The kind of the configuration, it differs ever so slightly from service mesh to service mesh, but as I say, the concepts are broadly the same. So we're going to look at Consul today, but literally I hope you're going to walk away and you're going to be able to apply this regardless of which tool you're using. So here's a simple sort of example. So I've got two services here. I've got a web service and well, in this instance, I've got a database. So how things work in terms of communication, my web service wants to talk to a database, could be another service, it doesn't matter, is that I make a request to the proxy. So my proxy is configured by the control plane. So I kind of make a configuration to state that web is allowed to talk to database, that kind of allowable security rule. Web talks to proxy over localhost. Localhost then forwards the request on to the proxy for the database, which then forwards the request on to the end application or the database service. And that happens completely transparently for you as the developer. You don't need to know that. You're kind of dealing with, in the case of Istio, but a standard kind of Kubernetes service call. In Consul, you're dealing with a call to localhost. But it's inside this proxy. It's where you're going to offset all of that code if you're using, like, say, the Hystrix library with your Java services, or if you're using a kind of a Hystrix compatible library in Go. You take that out of the application code and you're moving that into the proxy. So you're driving all of these things via configuration as opposed to actual implementation of code. So what do you get? Well, you pretty much get application resiliency pretty much for free. You can configure things like timeouts. You know, like cloud networking is as wonderful as it is. It occasionally goes wrong. You have problems with kind of transient failure, so you need to be able to do things like automatic retries. Service discovery is a really kind of broad concept and something if you've been using Kubernetes for a while, you'll be very, very used to. But you know, you got to kind of picture this as a problem that an application needs to know the location of another application. If you've got 50 instances, because you're horizontally autoscaling those across a cluster which has 5,000 nodes, like how are you going to manage that IP address, location? How do you manage that load balancing? So, you know, again, it's a sort of a construct which you're going to get for free. It's something you just don't even need to think about. Importantly for application development is distributed tracing. So the ability to be able to see a request flow through multiple services, being able to see things like latency, timing, information like that, being able to see logging information and being able to see error messages and have that correlated into a single trace graph is incredible. It really, really helps you to kind of diagnose problems, to be able to discover where there are issues. Like MTLS, this I think is the unsung hero of service mesh. What does it mean for you as a developer? Well, it means you don't have to deal with MTLS. So if you're a Go programmer, if you want to implement MTLS into your service, well, the first thing is you've got to be able to configure your HTTP server using TLS certificates. Those TLS certificates have got to come from somewhere. Operations problem, fair play. But you've still got to make that configuration. Then you've also got to configure your service to use client-side certificate validation or to fulfill the MTLS flow. And I'd just rather not do it. And the nice thing about the service mesh is it just does it for you, and it does it transparently, so we don't even need to think about it. We're going to get that security literally for free. But debugging. Distributed systems are complicated. They're more complicated than monolithic systems because they're distributed. But the distributed nature gives you the availability, and it gives you the performance, and it gives you the speed and all of the great things that we need. But how do you debug it when something goes wrong? Trolling log files. You can look at kind of observability to find out that there is a problem, but how do you find out what the problem is? Is it an edge case? Is it something to do with the configuration of the system? It's a really difficult problem, and it's not really something that you can solve with format.println. Well, you can, and it takes you a long time, but being able to actually attach a debugger into your production system like we're going to show you today is a really, really wonderful thing. Being able to replay an error message that a production system has generated straight into your debugger of your application so that you can step through and identify exactly what and where when things went wrong is a great thing. And seriously excites me.
So we at Solo, that's the lens through which we're looking. How do we narrow in on the difficult parts of operating a service mesh and a microservices style architecture and solve those problems? So one of the things that Nic was just talking about is the ability to debug. The first open source project that Solo did was a project called Squash. I'm just curious, it's kind of an odd name after a vegetable. How many people have heard of Squash? Just kind of curious. Okay, a couple. And so Squash is a multi-language distributed debugger. So if you're going to build your services, build your application in services, distribute over multiple different deployments, and maybe even multiple languages, how do you connect up to them and do a more familiar step-by-step debug from your IDE, because you're used to, as a developer, working from your IDE. How do you do the step-by-step debugging across potentially multiple services, potentially across multiple languages? Now, that's something that developers leverage in their own environments, on their own laptops, maybe in a shared development environment. But once you start to get into IST, UAT, production, all that stuff, you don't get to just connect your debugger up to those environments, right? Now, what we're going to show you today, and as part of the tutorial, is in a mesh environment, the types of things that we can do, like that, because the requests are going through the data plane, through the different proxies, is we can see those requests. Now, we're going to follow a similar pattern to what OpenTelemetry did, where as requests are coming through, we're going to attach some correlation IDs to it and build distributed traces out of these spans that we collect. That's what OpenTelemetry will do. Now, OpenTelemetry is really just grabbing things in the headers. That's the challenge. It's not going to. It'll help you identify what the hops were and where the slowdown might have been, but that's about where it ends. So with this the approach that we're taking, and we'll show you today, is because the proxy is in the data plane and can capture the requests, as you go through, the requests are going through the different graph, different services, things are responding, and if there's an issue, or if everything works fine, then we'll capture those requests, but then throw them away. We're not interested in them, because everything turned out fine. But if things did not turn out fine, then the requests that we've captured and the context and the order in which the requests propagated through the system, we can capture them, save them, and then take those requests and replay them in a different environment, one where you can connect up your debugger. All right, and so that's the workflow that we're going to look at today. We're going to look at deploying our applications in the service mesh, using the mesh to identify issues and help us figure out where the issues are. We're going to add distributed tracing. We're going to look at the mesh for being able to bring out new deployments, new versions of our applications using Canary. And then we're going to look at debugging. Hopefully that works for everyone. Again, here's the link to the environment. This should take you to a page that'll give you a link to the fully automated environment that runs just through the web browser, or one that you can start downloading some of the tools that you can use to run things locally on your own machine. That sound good? So let's go to this. Let's go to this link. Oh, I bet everybody's on the internet, aren't they? Oh, all right.
This isn't a workshop for development workflow. What we're really doing is we work for the internet company here at the venue, and we're stress testing it right now. So thank you all for coming to help us do that.
So what we're going to do now is give a little bit of time to click on and boot up the Instruct environment, or download a tool here called Shipyard. If I zoom in, can you see it? All right. A tool here called Shipyard that will assist in setting up the environment through Docker. So we'll give that a few moments. I'll try starting it from here. Let's see what happens.
And I'm going to apologize in advance for my love for dark color schemes, because dark color schemes and projectors don't seem to want to play nice. We're also stress testing.
Hashicorp.
No, it's not Hashicorp.
Oh.
No, we're stress tested.
Okay.
We don't do stress. We're stress testing like a certain cloud. I won't mention which one.
Yes.
But they're pretty awesome. Don't show favoritism. The Instrict environment's pretty cool. What it does is it allows you to kind of build these interactive workshops. And what we do is we can actually, through the Instruct, which is a great tool, spin up these environments. The behind the scenes, like virtual machines are actually getting spun up, which have been imaged. It's just a really nice way to kind of get things running. In terms of like what we're trying to do with all of the tooling and the environment that you can actually download on your own desktop, it all just runs in Docker, so it's pretty uninvasive in terms of an installation. Working locally, it can be kind of nice to be able to play a little bit off-piste, rather than using the kind of the repos that we've got here today when you want to take things a little further. So hopefully that things will be useful.
How many people are going to run it locally on their own machines, following the instructions and not use the Instruct? Oh, awesome. Okay, good.
So as a representative for the conference Wi-Fi, it's going to be really cool to find out who's got a caching proxy server for internet traffics. I can see a question. I'll not go that way.
On the web version of it, once it starts the environment up and I say next, it seems to dump. It says I'm finished with
Oh, yeah, right. Good question. Don't press next.
If you press it seems like you can click on it again and it brings it up.
Yeah, you can just go back. If you press next, you can go back. Yeah, next is a trap.
How do I get a terminal in the instructions say get a terminal.
Okay, so in Visual Studio Code, if you want to get a terminal, you can either use the menu option, which I think is in the top left-hand side. There's like a little burger menu. Or you can use control, little, yeah, tilt, yeah. And command control P will give you the quick actions, and you can search through to do that. Oh, it might just be starting there. Try hitting me. Oh, that one there. Yeah. Oh, that's fine. Just see what, can I? That'll be fine.
How many people were able to make it to this page if you're using Instruct? Okay. Either one.
If you click next, then we're done.
How many people were able to, as the instructions state here, to run, to get the source code and then run this? And it comes up? Okay, excellent. How many other, I didn't see the hands. Just a couple? All right.
Sorry.
Yeah.
Oh, so Visual Studio Code, it literally is just Visual Studio Code. So if you do, I use Vim, so I can't remember what the command is. You can, if you see up on the left there where you've got the menu, you can find terminal.
Hey.
So burger menu, terminal, and then just new terminal, and it'll do a little pop-up terminal inside of VS Code for you. There is if you run it locally. Yeah. But
just a public service announcement. If you're having issues with the Instruct environment, turn off the various blockers and ad blockers and that kind of stuff that might interfere with the scripts that get run. All right. My own environment is all screwed up.
There's an awful lot of you. More than we might have anticipated, to the point of it's going to be really quite difficult to try and get help to all of you. I hope we can do so. We've got a few people who will be able to run around and help answering questions, but like really, if you do get stuck and you can't follow along, I apologize in advance, but keep watching the demonstration that Christian and I will be doing, because all of this information, you can play around with this as well at your leisure when there's maybe a little bit better internet connection and it's more comfortable from your own homes.
How do we get to the...
So I think...
Okay.
Oh, okay. Oh, yeah, you can go full screen as well.
Ignore the next button.
Yeah, don't press next, it's a trap.
My machine just went sideways on Docker.
Cool. Thanks, buddy.
All right. Let's try that locally too.
Oh, you need to run. You can put up with the country value as well.
Let's go through the getting started part. Get as far as you can to the getting started part, which will walk you through setting up the environment, exposing certain ports to be able to hit the services. So if you have the instruct page up, which I don't yet, then we'll want to follow the instructions to install the various, we have to install the example services. We're going to need to install an API gateway, and then we'll go from there. The service mesh is already installed as part of the image that we're using.
So if you've got, so there's a bunch of tools. If you want to use Minikube, there's a bunch of tools you need to install. So like Consul Service Mesh can be installed with a Helm chart, which is pretty easy. But then the tools that we're going to use today are, we're going to be using the Squash CTL, the Loop CTL, Gloo CTL, and a couple of other tools to install, which might kind of like take a little. Oh, yeah. Yeah, things, so Shipyard should work fine with like WSL. Docker crashed.
Yeah.
So yeah, we kind of on Windows, WSL, I think in WSL 2 works fine, but
Nothing's coming up.
If you're on Instruct, how do you get to localhost?
so localhost on Instruct, I think in the documentation, use Docker host, not localhost.
The web browser.
Oh, so from the web browser, you don't need to use localhost because we've already mapped things like the services to tabs.
Come on. Okay, let's see if I can do this now.
Instruct a couple of minutes to kind of download and install and create the VM and things. Do you want to switch out my computer?
Maybe. Oh. Mine seems to be struggling pretty bad. Instruct doesn't want to come up.
Flip things out to my laptop.
Get yours, yeah. What do you have? HDMI directly?
USB-C.
There you go.
It's a path thing. Which platform? That's weird.
How many people are blocked? Like Docker images are taking forever, Instruct is not up. All right. Yeah.
Shipyard is claiming that reference does not exist.
Is that the one, the vault thing? Is it saying something about vault? Oh, there you go. Let me go check to see what's going on. All right, who's got issues?
We got this far. Is you know network null, right?
Oh, yeah.
Click web.
Click on the service.
It's been a few minutes. Also, which address does web point to? The localhost one or the search one? Which is? Because there's two in the instruction. One /UI, one is /search. Which one is this tab?
it doesn't like my computer. It's cool.
All right. So yeah, one goes to the UI.
Which one is web? This one? Either way, it doesn't work. So
Yeah.
Let me put the
Plug it into the second one.
Oh, okay. Sorry, I'll just put the original back in.
Yeah. Was it working fine before, or did it stop working?
Well, we decided to switch computers out because we were having a couple of issues.
etc., then that'll be active. So it's
What if
already
you're trying to
routed.
get to the Jaeger screen? Or
So the Jaeger one is the fourth tab, which is called Jaeger.
So okay, so they're all. So web is
We
just.
already mapped them, so they're already waiting for the service to come up.
Yeah, it doesn't matter about that one. We'll just, it'll be fine.
So the web. So web is supposed to be the service itself. Jaeger is.
no, like when it says go here, where is the equivalent of here?
We'll be okay.
Web.
That's web. So then how do you get to here?
That's the Jaeger one.
Thanks,
That's,
buddy.
That's Jaeger? Okay. How would I know that? Oh, okay. There's the word Jaeger. Yay. Okay, cool.
So web is not loading.
not for you either. Oh man.
Okay, so there's an issue.
Oh, there's Jaeger.
Yeah, Jaeger's
Jaeger
good.
works?
Jaeger's up. Yep.
Oh,
Jaeger's
I
up.
see.
Yep.
Okay.
No problem there. Let's just Jaeger.
Okay. And then code. Now from here.
Yeah, it changes back every time you switch.
Oh, does it?
All right. So let me zoom this up here.
Everyone else? Everything's good? Everybody good over here? Yeah. Oh, it's still wet?
So I'm in Instruct, but already this time though I should be getting to
So under instruct,
Expose Jaeger service, but not the web service. Some people
The web service comes, I think, a little bit later down as well.
instructions say expose. Some spaces.
doesn't work. Where should I be going?
if you go to instruct, go back to instruct.
Sorry.
So web should be the regular service. This tab should be the Jaeger service that we end up with. So that works, and then when you click on Consul. Okay, so those services that are exposed are mapped correctly. For some reason, the web is not coming up. Web or Jaeger. Consul one's coming up. Hopefully it's still coming up. I don't know where still it has it. I don't think the Instruct environment was prepared for this number of people. Unfortunately. Yours is
Okay, so what I've got here is I've got my Consul service running, and I've got my Kubernetes dashboard. So localhost.
oh. Yeah.
So export kube config.
What happens if you run that? How are things going for you all?
We had a little blocker, but right now we're downloading shipyards.
Oh, okay. Is the internet kind of slow?
Yeah, and I had to turn on my hotspot. So
Oh, all right.
I'm running off of that right now, but it's downloading.
Okay.
I wonder if everyone doing shipyard is causing contention.
If what is?
Everyone doing shipyard at the same time. Instruct was going okay.
Oh, you actually, what happens if you click on web?
That's not
Actually, you know what? Web wouldn't
might not be available yet.
up because we didn't install the application. Okay, so that's fine. So that's good.
This now.
Okay, that's a network. Yeah.
Wi-Fi.
Yeah. Okay, because you're in the browser now, and okay.
So I think Instruct was okay, and that wasn't happening until everyone started doing Shipyard.
So Shipyard's actually just a bash script, but once you do Shipyard up, that pulls down Docker images and all that stuff. Yeah.
People doing it once.
Yeah. Once you've installed the applications, so when you just get to this part, the applications are? Yeah, it should be.
So we had to expose web before, right? But the image is still there, so people keep asking like, hey, am I supposed to see this?
So if you're doing it from Instruct, then it won't be, so 99 service should be on web.
UI, they won't see it.
Okay, so when you see the web UI, just ignore that for the time being. That image will clear up in a little bit.
But so the web service running on 99 should show up.
Yeah. Oh, cool. Yeah, I think I will. Because I'm. Yeah, if you don't mind.
Right, that's the Docker container.
Whereabouts have you got set to?
I think that's right. I think that was
buddy.
From yeah. And the instruct environment for some reason. Yeah, people are seeing that.
Okay, let me zoom this up a little. All right, so I've got things set up a little bit. I've got my web application running here, and I've got my service mesh control plane here, so I can see my API, I can see my sidecars, I can see the various different applications. So the way that the application stack works is you have a front end of web. Web calls into the API. The API then calls into the payment service, and the payment service calls into currency. So it's kind of a standard multi-tier sort of application going on, right? So one of the things that we kind of want to look at is the tracing. So we're going to look at this more in sort of depth in a little while. But if we kind of take a look at tracing and we just click on web here and we just go to find traces, so I can see a trace. So what is a trace? Well, a trace is that kind of flow of all of the communication traffic between my services. So I can see that web handles an upstream. That's a span. It then calls an upstream. So it's an action, another span. What we can see here, where we see this localhost 1991, is a trace that's automatically injected for us by the control plane. So these first two, I manually create in code. This third one is automatically generated for me. And we're going to look at this more in depth in a little bit. So we've got the sort of the API gateway. So kind of a common thing that we want to do. Christian, do you want to dive through? Want to take over? I can help out.
Pulled over here to get to help out.
So the kind of the common approach is that we're going to use an API gateway to expose our services.
So how many people are actually able to get to this part of the tutorial? Is it just one or two? Is it a handful?
Expose the services, but I can't get to the web.
Oh yeah, just ignore that for the time being. We can come to that after you've
What's that?
After you've
So
exposed the API.
when you're not seeing the web tab, have you already deployed the web service application?
Yeah,
So you won't see web until you get a little bit further down. So web will be exposed when the API gateway's up, and we've kind of made that publicly exposed.
How many people are at this part? Just a couple? All right, let me wait a second then.
So just run.
Just keep
I
going?
think the best thing is we just keep running through, and if people can keep up, then that's great. If not, we can kind of play along and later on.
Okay. All right.
I think people just run this.
So once you have the services deployed and you have Jaeger exposed, so you can see the distributed tracing, you can send some traffic through if you have access to that web service through the web tab. The next thing what we want to do is we're going to set up the Gloo API gateway. Gloo is a gateway built on Envoy Proxy, and that will tie in with any service mesh, including Consul service mesh, to allow traffic into the cluster through an ingress point. So if you follow this, this will install all the Gloo proxy and its control plane. And the interesting thing about Gloo and why we're using it here is because this will allow us to use the loop functionality that I mentioned. So in this particular tutorial, what we're going to do is capture the messages that fail when they come through the gateway. So that'll be later down into the debugging part of the tutorial. But for right now, just set up the gateway itself. And once it gets deployed, the gloo cuddle command should be on the web the terminal that you have in the console. And then from there, you can create the route that needs to go into the Gloo routing table to allow traffic to get into the web service. And then ultimately, when you call it, you should be able to see the JSON response. Yep. There's some folks over there that need help. Increase the font, yes, absolutely. Oh, this is your laptop. The next step is the distributed tracing.
So once we've got everything set up, so we've got our application installed. Now, I kind of touched on this earlier, but I mentioned that there are 4 services. But we're only seeing 3 of them here. So why is that? Well, we got to look at the distributed tracing. So what is distributed tracing? What does it mean for you as an application developer? So service mesh, it solves it's perfect. Everything is magic. You get everything out of the box. You get a lot of things out of the box. Distributed tracing, you get some of it out of the box. You don't get all of it out of the box. So why? Well, you don't get all of it out of the box because of what a trace is. So a trace is a collection of individual spans. A span is kind of like a unit of work inside your application code. So in this instance, I've got call upstream. That's a unit of work that I've defined as a span. I've got handle request. That's like an inbound span which is created when an HTTP handler is called. Now, if you look at what information I'm getting out of the tracing, I can see here that the duration of each of those individual things. So this takes 57 milliseconds, and it's a combination of a call to an API, and an API takes 48, which is a combination of all of these different things. What information it's giving me as a developer is I can see all sorts of things such as the request ID, HTTP method, kind of stuff that's really easy to kind of dig into. Gives me information about what's going on with the application. I can, of course, use this when something goes wrong. But why am I not seeing the payment service and the currency service? So I'm seeing payments here, but I don't see anything else. I don't see any of the inbuilt spans. The reason I don't see those spans is because the trace is going dead. So how does a trace work? Well, a trace works because you've got an association of span IDs. So a child span, which needs to be related to a parent span, has to be associated with the parent span's ID. When you kind of think about the way that that works, that this full trace document, well, it's spanning multiple services, multiple different processes on multiple different machines and nodes, potentially, right? So you kind of don't submit an entire trace as a single document. What is happening is the code is submitting the individual spans to the collector, and then something like Jaeger is putting all of those things together based on the correlation of the parent to child ID to build up this flame graph. So in my application code, if I look at payment service here, and I look at the handler. So what's going on? Right. So I'm using open tracing. Open telemetry, obviously a newer thing, but open tracing is still pretty serviceable. Under the hood, we're using Jaeger based on Zipkin. It's a pretty kind of popular and well-established standard. So in my application code, whether you're using Go, Java, Ruby, whatever you are, you're going to be doing a very, very similar process. So I'm creating a span. I'm starting a span and I'm giving it a name. So I'm calling it handle request. I'm doing things like just adding some arbitrary logging information. So in this instance, I'm adding a field which is service type, and I'm just saying that, well, it's just HTTP. I can see that in my code through this metadata that's available to me. And then I'm calling this finish, because a span defines the duration around a kind of a piece of work. So in Go, if you're not a Go programmer, defer means execute this at the end of everything's done. So I could have put that at the bottom, but this is the kind of the Go way of doing it. So then what am I doing? So I'm making a request. So my payment service here is making a request to the currency service. I'm not creating any sort of things around there, but this is where the kind of the trace is going dead. And the trace is going dead because when it's coming, things are coming inbound, I'm not picking up the parent ID. When things are going outbound, I'm not setting the parent ID. So how do we do that? Well, it's pretty straightforward. So what we do, again, we're going to kind of use open tracing, is that in the span for an HTTP request, something which is outside the code creation of the spans, I need to be able to define these HTTP headers. So the presence of these HTTP headers is what's going to allow me to associate my span with a parent, and by setting these on an outbound request is going to allow the upstream service to do the same association. In terms of the world of open tracing, what I do is I use this extract utility method. So the extract utility method is designed to be able to pull those headers out of the request and to create a span context, which is identified by the variable here, wire context. Open tracing obviously supports a number of different protocols, not just Zipkin, but the kind of the generic nature is that in your code, regardless of what you're doing, if you're using the open tracing library, you've got this kind of conventional approach. What I'm also doing is I'm just writing some sort of debug information to myself. So if I can't create this span context based on the presence of HTTP headers, which I'm just going to write that out to a log message. Shouldn't happen, but you never know. So where do I do that? I'm doing this in the beginning of my application here. So I'm setting that wire context. I've got my error message. So now when I create my span, instead of just creating a flat span like this, what I'm going to do is I'm going to create the span with the context. So I can replace this line here with this one. Still doing my log fields, but you can see here I've got this option here. Now, I just need to do my import because, again, everything is sort of package-oriented, so I'm just going to import the ext package, which all of this contact extraction comes from, and I can add that into there. Right, so what's next? The upstream. So I'm creating a span. I need to create a span for my upstream call. So again, I can use the open tracing start span. I give it a name, but again, I'm specifying the association to a parent. And in this case, I'm using open tracing child of to do that association. But I need to also be able to pass that span information as HTTP headers in my request so that when my upstream receives the request, it can decode it all using the extract methods to be able to propagate the parent and therefore for everything to work nicely inside of the trace. And I'm doing that using the inject method. So my HTTP request, I'm just injecting those headers that come from the parent span's context, and I'm just dumping them into that request so that when the outbound's made, I've got that association. So I do that here. Right. Oops. So then I've got that. I can save that code. I've made that modification. I'm going to build it. I'm going to deploy the new version of my application to Kubernetes. So I'm going to Docker build. In the right folder. Pretty much standard process. Obviously, you're going to do this through your CI system, hopefully. Building the new version of my code. I'm then going to push that to Kubernetes so that I don't have to push it up to a remote registry. And then finally, what I can do is I can deploy that new version into Kubernetes. So the version of the system is already here. I've created the new Kubernetes deployment here. So I've got all of that set up with the new image. Right. So let's push that. So kubectl apply -f tracing, what did I call it? Payments blue. Got my new version there's now running inside of Kube. So I can run this a few times just to get a little bit more sort of trace information, putting into here. But now look at my trace. Instead of that 8 spans, I've now got 15 spans. And the reason that I've got the 15 is because I've added that correlation of the parent ID in my application code. This is like a really important thing. The service mesh does a lot for me. It will inject things like the data planes information as a span, but it can't do this automatic association for you. It's something that you've got to do got to do manually. Now, what I've done there, though, is I haven't really taken a very quality approach to doing the deployment. I've just thrown that at production. Now, of course, I've got my unit tests, I've got things like that to be able to test what's going on, but will it work in production? And that's the kind of the key question. So one of the things about working in production is that where application might be tested, it might have functional tests, might have unit tests, one of the things you've got to think about is what are the configuration differences? Is there anything on the server that's different from your local environment? And the answer is most likely yes. Kind of a lot of bugs, no matter how many sort of things that you put around them, you can still find that you deploy something to prod and it just fails. So what you want to be able to do is to deploy things to production softly. I want to be able to have two versions of my application running in production. I want to have the old version and the new version, and I want to be able to send a very kind of increasingly gradual amount of traffic to the new version until I'm confident that everything is working as it should. Kind of concept behind that is, you've probably heard before, a Canary deployment. I'm going to use this blue-green situation. So the way that works internally is the service mesh is going to automatically manage that traffic routing. I'm just going to control and say, hey, I want 10% going to version 1 and I want 90% going to version 2. Because you're using this data plane, you don't need to put any application code to be able to control this process. All of this smarts is driven through the configuration of the service mesh. So my web service, it makes an outbound call. It's totally unaware that there is a Canary sort of situation going on. And that's kind of exactly what I want. So how do I do it? Well, I got a hypothetical scenario. So I was just using the standard Golang HTTP interface. Platform team have come along and they've thrown a spanner in the works. Platform team are saying, default, no good. You've got to use our specific package. Fine. So they've called it Sleepy Service. So I'm going to make another modification to my application. I'm going to replace the default HTTP client with this new Sleepy Service, which is going to be amazing. I'm told it's going to be amazing. Because platform team are never wrong. Right, so I'm modifying my code there. Let me run my unit tests. Let me just double check that my code is okay. So go test ... Okay, so my unit tests are passing. That means my application is good. It's good to go. I'm going to push it to production. Fine. So again, I'm going to do a Docker build. I'm going to increment the version number. I'm going to throw this up to version 3. I'll just take a little while. And then I'm going to push it. That's built. Just pushing it direct to Kube so I don't have to manually upload that to GitHub and test the Wi-Fi further than Wi-Fi's not doing good today. All right, that's pushed. So next step. I'm blue-greening now, right? I've got a Canary. So the thing around doing a blue-green is that I don't, whereas previously I just replaced the version inside my Kubernetes deployment, I don't want to do that. I want two different versions of the application running at exactly the same time. So to do that, I'm going to create two deployments. I've got my blue deployment, which is here, and I've got my green deployment, which is here. So how do I differentiate between a blue and a green deployment? Is it on the deployment name? No. In effect, what I'm actually doing is I'm deploying everything with the same service identity. Everything is just going to be classified as payment. Now, where things are differing is that I'm actually going to be able to get the service mesh to use metadata which is associated with the service to be able to do this traffic splitting. So you can see here I'm defining some service tags. I'm giving the identity service tag of this, the green to v3, and the meta version of 3. If you look at the blue, we've got a v2 and 2. So pretty much everything remains the same. So before I deploy that, though, to Kubernetes, then what I've got to do is I've got to look at the configuration. Because if I just deploy this straight away, what's going to happen is Kubernetes is going to start round-robining to both my new version and my old version. I'm going to get an equal distribution of traffic between the old and new, and that's not what I want. I want to be able to tightly control that. So to be able to do that, what I'm going to do is I'm going to use a configuration, the service resolver. This is specific to Consul. If you're using Istio, say, or Linkerd, a very sort of specific construct exists. But let's look at what we're doing here. So I'm giving it a name. It's kind of like a virtual service, calling it payment. Now, I'm defining these subsets. So I'm creating a subset of a service called Blue. The Blue service instances are the ones which are going to have a metadata of version 2. The green instances are going to have a metadata of version 3. The important part for us, in order to ensure that we're only sending traffic to the existing version until we're ready, is by using the default subset. So unless I configure any traffic splitting, all traffic is just going to go to Blue. So I'm going to apply that. So to apply that, I can use infrastructure as code, as I say, I don't want to talk specifically about tooling. In the Consul world, I'm just going to use Consul config write. I'm going to pass it the file, Canary payment resolver. So now I've written that. What I can do is I can safely deploy my application code. Kube, CTL, apply, -f, payments green, deployment. Right. So let's have a look. That should be up and running, right? So if I look in the Consul UI, look at the control plane here, then what I can see is I've got this service. It's called payment, even though I've got these two deployments, payment deployment green and deployment blue, but they're actually just a single identity. The thing that's different is I have this metadata associated with each of the service instances. I've only got the two service instances there, but you can see that I've got metadata of 2, and I've got a service instance here with a metadata of 3. Looking at just my web UI, I can refresh this as much as I want. I'm always just going to hit the v2 of my payment service because I'm not doing anything else. I haven't told it to use any other versions. Right. So what's the next step? Well, the next step is that what I need to do to be able to start splitting my traffic is another configuration. I want to define a service splitter. So I've got my new configuration element. I'm going to do some traffic splitting. Again, it's got a name of payment because it relates to the payment service. And I'm defining these splits. 2 splits. I'm just going to do straight 50-50 for the purposes of a demo. In a real-world production environment, you're going to use much, 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 much lower numbers. How low? you're going to use as low a number that will allow you to get meaningful information to determine if the new version of your service is working. And that's going to depend on the service utilization, the number of instances, size of your cluster, and all sorts of things like that. But for this, we're going to do 50-50. We're sending 50% of traffic to blue, and we're sending 50% of traffic to green. In the same way, I'm just going to write that to the control plane. Console config write, Canary, payment splitter. Oh, I'm not Kubernetesing. Right. So that's been written to my control plane. Well, now, when I refresh, oh, hang on. What's going on? Well, it was working. But this one seems to be behaving a little bit strange. Why could that be? I mean, my code is perfect. Isn't it? Well, maybe not. So again, let's figure out what's going on. Let's dig into our traces. Well, I can see here that there are 8 errors. So let's look at that trace. So I can kind of see here that there's an error has happened inside of my payment service. Oops. Again, I can dig through this information, but what I need to do is I need to start debugging this. Ordinarily, if you were running in production, what would you do? Well, the thing that you would do is you would roll that straight back. You would identify that there's an error occurred, and you would reverse that. You would set your traffic splitter to be 0% for the blue version, for the green version of your service, and you just back it out. Again, for the purpose of the workshop, this actually allows us nicely to be able to segue straight into debugging. And we can show you actually how we can live debug this service in our production cluster, and how we can show you exactly where the problem is, which gives us great ability beyond just doing the kind of the standard format of print line or looking at log output.
All right. So, am I on? Can you hear me? Yeah. All right, I'm on. All right. So, like Nick said, we made a new deployment. We found some errors in our new deployment. We're able to look at the tracing, and we're able to see, okay, this is erroring out now. Well, if we're in a production environment, we're not going to be able to connect up directly to our new service to be able to debug it. We're going to need to do some additional, we have additional tools to be able to do that for us. But before we get to that, I want to familiarize you with the Squash debugger. So I mentioned this earlier. Squash is a distributed multi-language debugger. What it does is when you're running in Kubernetes and you want to attach your IDE to a single service or any number of services, you need to get the debug port open on the application. You need to spin up the debugger. You need to attach all of the piping to be able to port forward it to your local machine so that you can use your IDE. And all of that complicated stuff that happens inside of Kubernetes, that is what Squash takes care of. Squash takes care of the plumbing. Finding out exactly what process on what host and what container, and starting up the debugger, attaching it to that, port forwarding it back, and so forth. So that's what Squash does, and that's what we're going to take a look at here. So in the tutorial under this section, we are going to attempt to run Squash from within the IDE. So we have the VS Code packaged up and ready to go. From within VS Code, you should be able to run this. Squash is a plugin, comes as a plugin for VS Code. It also comes as a CLI tool, so you can use it from the command line. If we come over here, down here for a second, go back to our handler. Hopefully so if you do Command-Shift-P, if you're on a Mac, or Control-Shift-P, just like in VS Code, you can get to the various plugins that you want to run. If we start typing squash, it doesn't have zoom in. You should see it filter down, and if I hit squash on debug pod,
I don't think we set any breakpoints.
Sorry.
No breakpoints.
Not yet. Yeah. So from here, we're going to select the namespace for the application that we want to debug. We can see now that there's a listing of the various services. Through various other means, we figured out, okay, in this general area, maybe the new deployment, the green deployment was something that we should take a closer look at. We can filter down, click on that. Now, inside the deployment pod, the service mesh is also running. We see the Consul or Envoy running in this case right next to the payment service, but we want to debug the payment service, so let's click on that. And then lastly, this is a Golang service. We're going to attach the Delve debugger to it, and we'll do that and give it a second. What this is going to do is spin up a pod within Kubernetes that is based on the Delve debugger. It's going to find out which container is it that you want to debug, on what host, and find that process ID, and then attach the Delve debugger directly up to it, if it comes up. Sometimes it takes a second.
Yeah, it'll just take a little while to pull the debugger first time. Just run the debug command again.
Cross your fingers this time. Just takes a little finger crossing. There we go.
Cool.
Now we've attached. We've switched to debug mode. And now what we're going to do is we're going to set a breakpoint and cross our fingers there. That looks good. Close that off. And now what we're going to do is we're going to call into our service, and we saw that it failed. If I click it again, that one, so we're doing the 50-50 split from the Canary, right? But this call succeeded. Now if we click it here, oh, that one worked too. All right, come on, 50, where's the 50-50? All right, here we go. We got into a situation where it's not working from the UI. If we come back to code, we should see that the debugger caught that when the request came into this failing service, Squash and Delve together caught it and brought it back to the IDE. Now, from the IDE, we're just using the regular Golang debugger, and we can step over our calls here, and the service is running remotely. Remember, this is, we're able to step through, and we can see, okay, that looks all right. Let's send that. All right, let's move past that. Maybe to speed things up a little bit. We get to that part. And then we try to step over that one. Oh, I didn't. Oh, I need to do the request. Step over that one, and then it sits and hangs. So we're able to step through the code, evaluate the call stack, evaluate the context variables, and then we got to a point where now the thing just is a black hole, right? It just sinks, and it's not returning. Now, if we do wait long enough, the sleepy client will relent, and we will be able to recover and continue on. But we can see, all right, this is a problem. This is an issue. We need to address this. So it continues on. Now, this is here. We're going to stop the debugging for a second. Now, this is fine if we're running in a local environment, maybe your local Kubernetes, but if you're running in production, then this is not necessarily something that the platform team is going to allow you to do, to connect your developer laptop up into production. So what we're interested in doing is finding a way where we can reliably recreate that issue with the same version of the services that are running in production in a different environment so that we can safely debug in that environment. So if we scroll down into, so when you go back and do this for yourself, you can go through the guide and step by step with these images here to help you debug the sleepy client. What we want to do is use a tool called Loop. And Loop is a capture and replay mechanism for Envoy proxy-based gateways. So now, in our demo here, what we're going to do is we're going to set up the API, the Gloo API gateway, which has Loop in it, or the capability for the gateway to capture from within Envoy. And then requests that fail, what we're going to try to do is capture them and then replay them. All right? So the first thing that we're going to do is we're going to install Loop. Oh, can I not? Well. I'm going to install Loop. Oh, we didn't install Gloo yet. Let's not do that. So in the getting started part, we were supposed to install Gloo. Didn't happen, but I will do it now. Install Gloo. Delete. Apply. So we'll give that a moment. And then we'll install Loop. Come on. So Loop is up and running. Gloo is coming up. We'll give that a second to come up. And now we have Loop running, and Loop running in the Kubernetes cluster here means when a request is going through Envoy, and we've enabled Loop to do the capture on certain requests, ones that failed are the more interesting ones, and I'll show you how we do that in a second. But when Envoy captures the request, then it will send it to the Loop server, which will then store it and categorize it, especially if there's multiple requests, part of a single request thread coming in. Loop will do the, well, how do we put it right in right order and that kind of stuff. But for right now, it's pretty simple. When a request comes in, it fails, we're going to capture it and send it to Loop. Loop will hold on to it. And from there, we'll be able to replay it. So if we come back here, everything's up and running nicely. So now the next step, the next thing that we're going to do is from our terminal, what we want to do is be able to use the loop CTL command. So if we come back here and type loop control. Oh, this didn't get updated. So the loop control CLI will allow you to connect up into the loop server and instruct it to do the replay when it captures the things. But we don't have the loop control installed here on this particular VS Code. Is there a way to push the update? Actually, you know what?
Let's just install it.
Yes. What requests are for which users that you said? So the goal is to, if you have, we're going to try to piggyback on open tracing So if you have open tracing correlation IDs and so forth, then we'd be able to figure it out that way. We've toyed with adding other headers to do correlation IDs, but you know, if that's just going to be another issue. So ideally, we're going to be able to do this on top of an existing correlation system. Otherwise, you'll have to force the developers to include additional metadata to do that.
If there's like an authorization header, will it grab that and play it back?
So we're able to grab the raw request. Now, when it gets to loop, we haven't built the UI and the management capability for this yet, but the idea is that once we grab that raw request, that we can screen out any very environment-specific headers where you need to, or content where you need to, right? Because if you're passing production passwords and tokens and that kind of stuff, you might want to mask those or inject different ones for when you're in a different environment.
But if it's like a JWT token, sometimes the application is looking for that, and that'll dictate some of its behavior, right?
So you can. So I mean, that's what I'm saying. We have, but I know we've talked with certain customers who said there are environment-specific things that you cannot take out of production. But we will have access to the full raw requests, including all of the production JOTs and so forth that get passed, and you are able to take that if that's something that you're willing to do. Yes. Yes. So the VS Code debug, so what Squash does is if you have a Java application or a Golang application, and we're really close to Node.js support, one of our customers asked specifically for that, we're able to, you can just use the regular VS Code debugger and do Java, Golang, Node.js all within a single IDE. And what it does is on remote Kubernetes, so the way that I showed you right now, what it does is it attaches up to the process and attaches the debugger and pipes it all the way back. But for a lot of people who actually use this, that's too insecure, for even though it's in a development environment. If it's in a shared environment where they have, they don't want just random other teams to be able to connect up into their system, what they do is they specify so we use a CRD to say that this debugging is allowed to happen for this particular user, and we're able to leverage Kubernetes RBAC to do that. So it's when we start to get into the more secure way of debugging, that's where, and then propagating that plumbing and all the way back to the ID, that's where the value of Squash starts to become more apparent. I mean, if you have the Delve debugger, you're able to open the ports and so forth and use VS Code remote, then that works fine as well, yeah.
So it's actually running the process that's on your cluster as opposed to
Yes.
presence, which seems to be running it locally.
Correct.
And hiding traffic.
Correct, exactly, yep. Are there any other questions? We're actually 2 minutes away from ending. Yes, what was the question back there? Here, I'll come to you. What's?
How does it know how to not kill the code when you're breaking into where you're debugging code?
So the question is, if you have a certain probe inside the pod already?
I'll check if the service is still running.
So if, for example, you have Kubernetes health checks and liveness checks and so forth, and then when Squash runs into it, whether or not it gets killed because Kubernetes doesn't return. I think the answer to that is, I don't know, I haven't seen that. But that's a valid point. We're going to have to come up with a way to solve that. But the users that we've seen debug their applications like this, they're not doing it in production, right? So requests are not actually, we're not impacting the users. In lower environments, maybe they set their liveness thresholds high enough that it doesn't get killed. But I haven't seen that. But good question. Yes. So Loop CTL. So Loop right now is the open source components, the open source parts are in Envoy. It's the tap filter in Envoy that we're leveraging. The Loop server right now is not open source yet. That is something that.
Yeah, sorry, it's a few teething problems.
That is something that will be coming though. It's not open yet.
The YouTube live stuff will be a little bit easier to run through.
So the Loop CLI and the minimal parts of Loop we are planning to open source. The UI and the workflow stuff that we build on top of it, that will be
before Christmas, or whether we do it just after Christmas because we don't want to like end up doing 2 sessions. And then
yes, one more question. Yep.
Thanks, Wash.
Thanks.
Work with other API gateways, or just?
It's Envoy based. So an API gateway built on Envoy that uses the tap filter. We can do it with Istio. With the Istio sidecar proxies. We can do it with the Consul sidecar proxies. Right now, the tap filter that we're using is we've pushed it upstream, but it's not in the master yet. But that is something that will be coming. So that any distribution that uses Envoy should be able to. We should be able to leverage that to pull back. Yeah. All right. And I think we're supposed to end at 3:55. I think, right?
Yep.
All right. Well, definitely take a look at the guide. Run it locally on Docker in your own internet, and reach out to us if you have any thoughts or questions if things didn't work out right. And yeah.